So today we have a quite lengthy geometrical problem. The given data is very simple, but there are some points that we have to keep in our mind. The first point is that the length of these two segments, that is from here to here and from here to here, these two are of the same length. And the second point that's very important, that this point isn't the center of this circle. The center of the circle can anywhere other than this point, but it's not that point. So considering it at the center of the circle isn't correct, it will not give you a correct solution. So this was the point to be noted, and what we have to find is the area of this particular triangle when it has been given that the area of this square is 9 cm square. So let us see its beautiful solution. So yes, first of all we have that area of the square is 9 cm square, so we can have the side of the square, that is square root of 9, that is equals to 3. That's very simple. And before moving on further, let us discuss some kind of theorem. If there is a circle, there is the diameter, and you draw a nice square on the top of this diameter, means using this diameter you draw a square, and let this point be the center of this particular circle. Then this point is also the midpoint for this side of the square. This is the first thing. Now the second thing is that the length of these two segments, that is from this point to this point, that's this much segment and this much segment are going to be have the same length. So if this length is equals to a, then this length is also equals to a. So these 2 points you have to keep in our mind, that yes, the center of the circle will also be the midpoint of this particular square, hence for the base of the square, and that two lengths are going to be equal. So in this diagram we were having that yes, this much length is already equals to this much length, so let us label them as some kind of variable. So the variable I am taking is a. So if that is equals to a, this is equals to a, and as I told you, because of the square, this much length is equals to this much length. So if this is already equals to a, so the remaining is also equals to a, that's from here to here, so this is also equals to a. Now this much length is some kind of important length, because at that length the side of the square is some kind of divided. So let this much length is equals to m. Yes, this is also the side of the square, so it's equals to 3. Now let us have some thing that we can have, that is the area of this, not the area, the radius of this particular circle. So just having yes. Now consider this as the center other than that point. From this corner, if I draw a line segment to that point, so remember, if this is the center of the circle, a line segment is going to the circumference of the circle, so it ultimately forms the radius of the circle. So let the radius be equals to r, and as I told you, the midpoint will bisect the base. So as the base of this square is equals to 3, so after the bisect it becomes 3 by 2, that's half the length, and here is 90 degree because it is the square. So what we are currently having is a nice right angle triangle. The side is 3, the base is 3 by 2, and hypotenuse is equals to r. So we can have the Pythagoras theorem in this. So 3 square plus 3 by 2 the whole square gives me r square. So from here, very easy, we get that r is equals to 3 times square root of 5 upon 2. There's not any kind of messy calculations. We get very nicely that yes, r is equals to 3 times square root of 5 upon 2. So we have just have some kind other thing. From that area of the square is equals to 9 cm square, we derive the radius of this particular square, not the square, this particular circle. Now from the radius we will derive the value of a, that is this variable. How? Let me show you. This is the diameter. Here's the square standing. The square has a side that is equals to a, not the a, it's equals to 3, and these two sides are already equal, and in this particular diagram they are marked as a. So a and a, and as this is the diameter, so diameter is equals to 2 times the radius, and that is equals to 2 times a plus 3. Now we have the value of r, so r into 2 gives me 3 times square root of 5, that is equals to 2 times a plus 3. So from here I have the value of a, that is 3 times square root of 5 minus 1 upon 2. So as you can see, from the area of the square we got the radius, from the radius we derive the value of a. Now from a we will get the value of m. Let us see that very nicely over there. So changing the color for the value of m. Now from this diagram, this is the base. Look at this base of the square. This is the line which is just intersecting as a over there. Let it be clear, yes. So from here to here it's a, from here to here it's m. So ultimately we have that m plus a is equals to side of the square. Side of the square is equals to 3. Now in this particular equation we already have the value of a. So I can put the value of a so as to get the value of m. So doing that over here, so m is equals to 3 minus a. So 3 minus 3 times square root of 5, let it be clear, yes, square root of 5 minus 1 upon 2. So just zooming it over there, So m is equals to 2 into 3, 6. 6 plus 3, that's 9. So 9 minus 3 root 5, we can take 3 common out. So 3 taken common out. So 3 minus, let it be clear, yes. So we have that 3 times 3 minus square root of 5 upon 2 is the value of m. So as you can see, from the area of the square we got the radius, from the radius we got the value of a, from a we got the value of m. Yes. Now from m we can get the value of this hypotenuse in this particular right angle triangle. I can just change the color to show you which right angle triangle. Let the color be pink. Yes. In this particular right angle triangle you can have that. In that right angle triangle, yes. In that right angle triangle the side is equals to 3, the base is equals to m. So I can have the value of hypotenuse. So let us do that over here. So first of all, let the hypotenuse be some kind of variable, let it be equals to n. So from here we have that 3 square plus m square is equals to n square. Value of m is, that is 3 times 3 minus square root of 5 upon 2, it's the whole square, plus 3 square, that's 9, and that is the value of n square. So simplifying it over here, so 3 square 9, 3 minus square root of 5, the whole square becomes 14 minus 6 times square root of 5 upon 4 plus 9, let it be clear, yes, plus 9, and that is equals to n square. Taking 9 common out, so it forms 14 minus 6 root 5 plus 4 upon 4 is, let it be clear, yes, that is equals to n square. So from here we have that 9 upon 4 into 18 minus 6 root 5 is equals to n square. From 18 and 6 I can have 6 common, so 9 into 6, 54. Let it be 9 into 6 as it is. So 9 into 6 into 3 minus square root of 5 upon 4 is equals to n square. So as to bring n, I have to take under root over here. So now under root of 9 is 3, under root of 6, under root 6 as it is, under root of 3 minus root 5, under root of 4 is equals to 2, and that is the value of n. So from the area of the square we have the radius, from radius we solve for the value of a, from a we have m, from m we have the value of n. Now what we will do with all the things? Now the main idea, how we will find the area of the square. So just removing these things that are not required currently. Yes. Now only the variables over here. This was a, this was m, this was a, this was a, this was n. This is equals to 3. Let this be angle theta, let that be angle theta. Let this side be equals to k. So we have a very nice theorem. Let this be removed from here. It's taking the space. Yes. So we have a very nice theorem that if there is a triangle, not a theorem, it's the formula. If you have a triangle, this is the angle theta. The two sides are p and q. Then the area of this triangle is half sine of that middle angle. So sine of theta and product of the adjacent sides. So p into q. This is the area of this particular triangle. Half sine theta p into q. So in this particular triangle, I can have the area half of sine theta, the two adjacent sides in multiplication. So 2 times a into k. So I can have the value of 2 times a. Yes, I can also have the value of sine theta. This 2 was sine theta because of vertically opposite angle, and as this is a very nice right angle triangle, in this the value of sine theta is very simple, 3 upon n. That's why we solve for the value of n. So 3 upon n, we get a very nice value for the sine theta. We get the value of 2 times a. But k is still missing, so let us solve for the value of k. So I'm just drawing the circle to find the value of k. This is the chord, let it be clear, yes, this is the chord and this is the chord. Yes, in this particular triangle, this is having a length n, this is having a length k, this is having a length 2 times a, this is having a length m plus a. Look in this particular diagram. This much part is m plus a plus a, 2 times a, that is n, that is k. So these two chords I have drawn over there. Now what I can observe over here is the intersecting chord theorem. Intersecting chord theorem is that if there is a circle, two chords are intersecting no matter at what angle. If these two sides are p, q, let it be clear, yes, p, q, r and s, then the product of p, q is equals to product of r, s. This is the intersecting chord theorem. So we can apply it over there to find the value of k. So from here we have that n into k, writing it over there. So we have that n into k is 2 times a into, let it be clear, yes, 2 times a into m plus a. Yes, 2 times a into m plus a is equals to n into k. So from here n is, we have the value of n, we have the value of a, we have the value of m. So m plus a, we have a very nice value. So from here we can have the value of k. So k is equals to 2 times a into m plus a upon n. So solving for the value of k. So 2 times a becomes, first of all, the value of a was Yes, over here 3 times square root of 5 upon 2. So 2 times a becomes 3 times square root of 5 minus 1. M plus a, let us have the value of m plus a. We have the value of m, where it is. Yes, this is the value of m, this is the value of a. And from this diagram, or else we were having a nice equation. Yes, m plus a is already equals to 3. We were having an equation. So putting that over here, m plus a is equals to 3 upon n. And n is already having a value that is 3 times square root of 6. I have just recalled the value, that is 3 times square root of 6 into square root of 3 minus square root of 5 upon 2. So from here 3 and 3 got cancelled out. Yes, 3 and 3 got cancelled out. So k is equals to 2 gone on the top. So 2 into 3 6 into square root of 5 minus 1. Square root of 6 we will just do rationalization. So square root of 6 into square root of 6 and upon 3 times under root 5. So 3 minus under root 5. So 6 and 6 got cancelled out. So we have the value of k also, that is square root of 5 minus 1 into square root of 6 upon square root of 3 minus square root of 5. So this is the value of k. A quite radical value, but it's okay. We have the value of k. So we solve for the value of k. We have the value of 2 times a, and we can have the value of sine theta from that particular triangle. So sine theta in this triangle, as they were vertically opposite angles, so sine theta over here is equals to sine theta over there. So sine theta in this right angle triangle is 3 upon the hypotenuse. So means sine theta is perpendicular upon hypotenuse. So perpendicular is 3, hypotenuse is n, and n is equals to 3 times square root of 6 square root of 3 minus square root of 5 upon 2. So from here 3 and 3 got cancelled out. So we have that sine theta is 2 upon square root of 6 into square root of 3 minus square root of 5. Let it be clear. Yes, this is the value of sine theta. So all the requirements are fulfilled. We have the value of sine theta, we have the value of k, and the value of 2 times a we already have. So we can just have the solution for the area of this particular triangle. So writing it over here. So area of this particular triangle is half of sine theta into m plus a, not m plus a, into 2 times a, sorry, yes, 2 times a into k. So half of sine theta is having a value that is 2 upon square root of 6 square root of 3 minus square root of 5. Yes, this is the value of sine theta. The value of 2 times a, so value of a, where it is, yes, it is 3 times square root of 5 minus 1 upon 2. So 2 times, so 2 and 2 got cancelled out. So we have the value of a, that's 2 times a is having a value that is 3 times square root of 5 minus 1, and the value of k we have just found over here, that is square root of 5 minus 1 into square root of 6 upon square root of 3 minus square root of 5. So yes, let it be clear. As it goes small, the handwriting becomes a little bad. So 3 minus square root of 5. Yes. So from here, let us see the what terms are going to cancel. Square root of 6, square root of 6, 2 and 2. Square root of, 5 minus 1, square root of 5 minus 1 into square root of 5 minus 1 becomes square root of 5 minus 1 the whole square. So 5 plus 1, 6 minus 2 square root of 5. So we can just have 2 common out, so 2 taken common. So it becomes 2 times 2 into 3 minus square root of 5. And remember, this 3 is in multiplication. So 2 into 3 gives me 6 over there. So the numerator is 6 times square root of 3 minus square root of 5. Now in the denominator, only things are square root of 3 times square root of 5, square root of 3 minus square root of 5. So square root of a into square root of a becomes a. So similarly over here, in the square root we have the same terms and it's twice. So it becomes the only single terms, and that's outside the bracket. So 3 minus square root of 5. So from here, this and this got cancelled out, and what was this all things equals to area of the triangle. So we get that area of this triangle is nothing but it's equals to 6, and that's our answer. That if in this kind of situation the area of this kind of square is equals to 9, we have that area of this triangle is equals to 6, and that's our answer. So this was my method to solve this particular equation. What we did is, from the radius we got the value of a, from a we solve for the value of m, from that we solve for the value of n. The method to solve for the value of n was to find the length of k, to find the value of sine theta. All the things were related. From this area of the square we got the radius, from radius a, from a m, from m n, from n k, from k, and after this all the things combined together to give us the area of this particular triangle, that is equals to 6 centimeter square. So as you can see, this problem has a quite length. So this was my method to solve this particular question. If you have any other method and it's very shorter than this, I will just appreciate it and again make a video on it. So for doing, you can just have comment or else you can DM me on my Instagram, link is in the description. And someone gives a better solution to the same question and we can show it to our viewers, it spreads the knowledge.